So I'm going to provide you a little bit more details regarding STM32N6 power supply domains. So as you already know, the N6 is based on 16 nanometers technology, what means that natively it is 1.8 volt platform. And this is flashless MCU. By native 1.8 volt platform, I mean that the highest possible speed for data exchange via GPIOs is possible when you switch to 1.8 volt power supply. However, 3.3 volt power supply is also supported, but the power supply range is not continuous, as you can see here. Let me switch to the laser pointer. So this is a very important feature, not continuous power supply range. You can select between 1.8 volt range or 3.3 volt range. The range in between is forbidden. And what is also important, when you select 1 volt power supply range, the IOs are not 3.3 volt tolerant, and the same for 3.3 volt range, the IOs are not 5 volt tolerant. Analog domain voltage, maximum voltage, especially for ADC, is 1.8 volt only. The same for external high-speed oscillator and some particular pins like PDR on. It is power down, reset on signal. The configuration of the power supply range for the given power supply domains is possible using one-time programmable bits. We have several independent power supply domains like VDD, VDDIO2, 3, 4, and 5. And what is important, default power supply range is 3.3 volt. So once again, important message, if you would like to maximize the speed of data exchange, for example, with external RAM or flash, you would need to switch to the 1.8 volt. Here you can see the power supply domains. We have two groups of power supply domains. The main power supply domain, like VDD A1.18 A on, what stands for always on, like VDD, and for IOs, and VDD core. This is the power supply for the core of the microcontroller. Then we have several secondary power supply domains, like supply of external memories, so VDD IO from 2 to 5, supply of PLL, supply of USB, supply of camera interface, and analog domain. Of course, we have backup power domain, so the VBAT pin is present on the N6 microcontroller. So you can connect external battery if needed. Here you can see the list of the power supply domains. No need to go through details now. However, once again, to remind you, we have main power supply domains like VDD, VDDA, 1.8 always on, VDD core, and VDD core, as you have seen on the previous slide, depends on the SMPS. And VDD core can be supplied both by internal SMPS, and for this use case, we need another main power supplies to supply internal SMPS, or VDD core can be supplied by external SMPS. We have two ranges. The typical, the normal VDD core voltage is 0.81 volt, so you can achieve up to 600 megahertz of core clock, or 0.89 volt, the overdrive mode, to increase the core frequency to 800 megahertz. And once again, to remind you, the power supply for the analog domain, especially for the ADC, is 1.8 volt. What is the most important difference comparing to the most of the STM32 microcontrollers, or the rest of the STM32 microcontrollers, is that we need sequence power on procedure of the N6. So here you can see the sequence, and we have two use cases as already mentioned: internal SMPS. So I'm going to discuss now internal SMPS use case and external SMPS. So for internal SMPS, we need two voltages to be always on, to be on as a first action. VDD, so power supply for the IOs, and VDDA 1.8, always on. For example, this is power supply for OTP area, but not only. When those voltages are present and in the range, the power on signal is enabled here, and then the internal circuit checks the voltages, the power supply of the internal SMPS. So we have two power supplies of internal SMPS, VDDA 1.18 PMU, VDD SMPS. When those voltages are okay, internal SMPS is enabled, and we are waiting for the output voltage of the SMPS to be established. When it is okay, then VCore is supplied by internal SMPS. When VCore is okay, we can start the internal oscillator, load the OTP bits, and switch to the running mode. Okay, so it was internal SMPS use case. Now there is a external SMPS use case. So we have external regulator to supply VDD core. So once again, we need VDD and VDD A18 A on to be present. Then if present and voltage and levels are okay, the power on signal is enabled, and this power on signal enables external SMPS providing VDD core. When VDD core is okay, the oscillator starts, loads the OTP bits, so performs hardware initialization and switching to the run mode. What is important in external SMPS mode is to, as soon as possible, switch off internal SMPS because it is enabled by default. The hint for you for both modes, so the internal SMPS and external SMPS, we have power on signal, and this power on signal can be used to control the power supply of secondary power domains. For example, the domains for external RAM and flash, to reduce the leakage current, for example, in standby mode, so in standby mode, in low power mode. Because in standby mode, the power on signal is disabled. I mentioned in the beginning that the highest possible speed of external interfaces, serial interfaces like XSPI, is possible when the power supply voltage is native to the technology used, which has been used. So it means 1.8 volt. By default, the power supply is set to 3.3 volts. But for example, on the Discovery board, we have external NOR flash and we have external PSRAM connected to the XSPI interface. Those memories are supplied by VDD-IO3 and VDD-IO2. And by default, the power supply range for those domains is set to 3.3 volts. While we would like to achieve the highest possible bus speed, so it makes sense to switch to the 1.8 volt. Also because if you would analyze the schematic, you could see that those memories are supplied by 1.8 volt. So we need to configure the relevant OTP bits. This is the OTP word 124. In this OTP word, we have an option to configure the secondary power supply domain range, in particular VDD-IO2 and VDD-IO3. Default value of this word is 0. Then we can configure the OTP bits both using Cube Programmer or by firmware, and you have dedicated example within the cube examples, HAL cube examples. So we need to configure those 2 bits, bit number 15 and 16, because VDDIO2 and VDDIO3 are supplied by 1.8 volt. So the supply of the external RAM and flash. So we are configuring using, for example, Cube Programmer, and now we can achieve the highest possible data exchange speed on the bus for external memories. What is important here, and a hint, very important hint for you, please be careful when configuring the power supply range, because if we would put here 3.3 volt while the bits are set, so set for 1.8 volt, you can destroy the MCU. We have quite useful documentation. So, of course, the reference manual datasheet, but I recommend to you to be familiar with the 2 application notes. Getting started with hardware development for N6, and very interesting one, how to build discrete power supply for N6. Also an article on wiki page, how to program the OTP fuse bits. So thank you